Hello, a very warm good evening to all of you, and welcome to Unacademy. Welcome to this unique initiative where we are going to cover NCERT for the entire subject of geography. And this will be your only destination, whereby even if you are a beginner, even if you are a proficient learner, for everyone, this will be the destination from where you can cover the entire subject of geography for the prelims as well as the mains examination. Now, geography being a technical subject, many of the times we oftentimes end up ratifying from one fact to another. As a consequence, in the prelims examination, whenever UPSC asks even a slightly conceptual portion, many of the candidates feel difficulty and they are unable to attempt the questions of geography. So, all that purpose will be solved by this series. Now, this series will be running from Monday to Friday at 7 p.m. And we will be discussing one by one every chapter so that your entire NCERT coverage is done. And NCERT is the major book and the basic book for geography. People will suggest you GC Leong, Savindra Singh, Majid Hussain, P. Dayal, Stroller and Stroller, all the different types of books. But let me assure you that unless and until you cover NCERT, no other books will make sense. And even in the past decade, if you analyze the questions, you will not find a question which was asked in the examination, which was not there in the NCERT, but there in any other book out there. So, Monday to Friday, do attend these sessions, set the notifications on, and within 2 to 3 weeks, have the complete coverage of geography. And on Saturday, we will be having a test so that whatever you have studied during the week, including the previous year questions, including the objective questions based out of the NCERT, you are able to assess yourself. Now, which is the NCERT that we will be covering first? We will be covering the NCERT of Fundamentals of Physical Geography, class 11th. Now, few of you might have this query or this curiosity in your mind that, sir, everybody suggests 6 to 12th. Why are we initiating the discussion from class 11th? I have not covered 6 to 10th. You need not worry. For every topic, we will start from the basics with the assumption that we don't know anything about that topic. And slowly and steadily, we will be building up the concept so that from very initial level, amateurish level, to the proficient level, you are complete when it comes to the subject. So we will be targeting this wherever required. We will expand beyond what is written in the book also so that the comprehensive knowledge is gained. Okay. Now, today we will be starting with the first chapter of this particular book, that is the origin of universe. And there we shall be talking about the theories such as the theory of Big Bang regarding the formation of universe. But I will give you a slightly greater, deeper background into the origin of the concept of universe. How did that evolve over a period of time? What was the nebular hypothesis by Immanuel Kant? The critical analysis, that is the advantage, disadvantage of the nebular hypothesis. Then also, we will be talking about how the Earth came into existence. What were the stages? What was the phase when Earth experienced rainfall for almost 7,000 to 10,000 years continuously? How the atmosphere evolved from the earlier stages to the present condition where we are able to breathe in and breathe out and we are able to have life on planet Earth. So that is going to be the entire coverage of this particular session. Now, we will start with a previous year question. First of all, we will take a look at that question, and by the end of the lecture, I expect you to be able to solve that previous year question on your own as well. Now, prior to that, an important announcement we will make after the previous year question. First of all, take a look at the previous year question here. Consider the following statements. This was asked in 2018. Now, what is this question about? The Earth's magnetic field has reversed every few 100,000 years. When the Earth was created more than 4,000 million years ago, there was 54% oxygen and no carbon dioxide. When living organisms originated, they modified the early atmosphere of the Earth. Which of the statements given above is or are correct? As beginners, we don't know. Or even if we have covered geography, let's assume we don't know this answer. Wait for the session. At the end of the session, I will ask you the same question. Okay? Now, an important announcement for all of you budding aspirants. We have come up with a very unique offering whereby it is a unique offering that is, it is not provided anywhere across the country. That if, let's suppose, you avail this offer at the lowest price of 16,999, if you clear the prelims examination, you are eligible for 100% refund of whatever money you have invested. And after that, in case you are not selected for the prelims examination, you get extra validity without any extra payment. So, this is basically us telling you this is how sure we are about the quality of content we are providing. Use the code IAS English, avail the maximum possible discount, and be a part of the journey. Now, first of all, before we start with the first page, first line. Now, this chapter talks about the origin and evolution of planet Earth. Here, when we talk about planet Earth and in fact the entire universe, mankind had always been curious about their role, about their place in the entire world or in the entire universe. And how do we know about it? If you take a look at the cave paintings, 3,000, 4,000, 5,000 years old, you will find that even the earliest of the cave paintings, they represent a human and the humans staring at the stars. So mankind was always curious that what lied beyond us, what is our position in the world, what is the reason for our existence, how did we come into existence. So when we say the universe, the concept of the universe has also been changing. Now, earlier there was the idea that Earth is the center of the universe. Everything across the world is actually moving around the Earth. And why did humans believe like that? Because the humans, when they would wake up, they would see the solar position in one place. And when they would go to sleep, they would see the sun going down, the moon coming up, the moon also going down, the stars also moving around the sky. So they came into that belief that the entire world, they did not know what the world was, but they came unto a belief that the entire world was moving around them. That model of universe, where Earth is considered to be the center of universe, that is considered to be the geocentric model of universe. Geocentric model. Now, what does this geocentric model of universe tell us? It basically places Earth at the center. Earth at the center of universe. Okay? Center of universe. Now, we were not sure what the stars were. We were not sure what the how the sun or how the moon got created. But this was the overall idea. Over a period of hundreds and thousands of years, various different civilizations, they started to realize that it is not the earth around which the sun moves, but it is the sun around which the planets they tend to move. Even when you talk about ancient Indian science, we were amongst the first people to come across this understanding that earth does rotate and revolve around the sun. So that basically paved the way for another model of universe, and that was considered to be the heliocentric model. Heliocentric. Heliocentric model basically places Earth at or Sun at the center. At the center. Simple. Very simple to retain and recall. Geocentric, geo means Earth. So Earth is the center of universe. Heliocentric. Helios representing Sun. So sun is at the center of the universe. But what was universe? We don't know. Right? At this point of time, The evolution of science had not happened to such an extent that we know about the stars, the galaxies. No, we had very little clue. It was only in the past 1,000 years that these developments they started to happen. The real substantial development which happened was by the individuals like Immanuel Kant. Now, Immanuel Kant was a great individual who had provided studies in various different subjects. When you study history, when you study ethics, when you study public administration, everywhere you come across the individual named Immanuel Kant. So, Immanuel Kant first gave the idea that basically how the universe could come into existence. This was a theory which was proposed by him way back in 1755 in his work Universal Natural History and Theory of the Heavens. Now, this Immanuel Kant basically he gave the theory about the origin of universe. But for Immanuel Kant, what was universe? For Immanuel Kant, universe basically meant simple, the solar system. That's it. Nothing more, nothing less. The sun and the planets at this point of time were considered to be basically the universe in itself. Now, this theory was reworked upon 40 years later by his pupil Laplace, and multiple other theories were also provided. But first of all, we should understand what was this nebular hypothesis and the nebular hypothesis theory provided by Immanuel Kant. Let us understand with the help of a chart, a graphical representation. So, here, in the very initial stage, Immanuel Kant assumed, right? For any theory, you assume something. For example, let's suppose if I have to make a theory about how a civil services aspirant studies, right? So I will make the assumption that the individual is interested in civil services, the individual is actually studying what is required for civil services, and then I will make a theory that first they will be attracted to some of the basic stuff, then they will go into the conceptual stuff, and so on and so forth. So for every theory, for every hypothesis, there is a basic set of assumption which is made. So Immanuel Kant, when he made his basic assumption, what was his basic assumption? His basic assumption was that a huge cloud of gas and dust existed in the space. A huge cloud. Okay. Now, that huge cloud of dust and gas, that was referred to as the nebula. So, nebula here refers to a large cloud of gas and dust. Now, which were the gases which were present? At this point of time, you had hydrogen and helium, which were dominant. But Kant did not talk about it. So he said that the nebula was cold, slightly diffused, and was rotating ever so slowly. Okay, listen to this carefully. There was a large cloud of gas and dust particles, and that cloud was cold and it was basically rotating ever so slowly. Right? Why was it rotating? Where did the nebula come from? Kant did not explain this. So, in any theory, wherever you come across those materials which are not explained, that becomes automatically the criticism of that theory. So, this is a major criticism of this theory. That where did that rotation come from? Where did that gas and dust particles come from? But he said that all these they were rotating. Now, eventually, if you had a very large volume of gas and dust particles, gaseous and dust particles, these gaseous and dust particles, they basically collapsed. Okay? They simply collapsed. And as they collapsed, they started being pulled inwards due to the force of gravity. Each of the particles pulling each other. So the entire gas cloud, the entire dust cloud flattened and collapsed. As they flattened and collapsed, the central portion became heavier. And the entire system, which was already rotating, the rotational speed started increasing. So that is where gravity causes the nebula to collapse inwards. Density and temperature eventually increased because everything started colliding, collapsing. So the density and the temperature increased. And as a consequence, the rotation of this entire cloud became faster. Now, the central portion was the heaviest one where all the gases concentrated. And as it was rotating, the inner portion, the entire disk which was rotating, now the inner portion was also rotating, outer portion was also rotating. But both of them, because their mass, weight, etc., were different, they could not rotate at the same speed. So that is why slowly and steadily they started separating. Right? They formed like large rings of materials which separated from the inner portion. This inner portion eventually led to the formation of the sun, and the other materials which basically separated, they eventually concentrated to lead to the formation of planets. That was, in a nutshell, the entirety of the detail of the nebular hypothesis provided by Immanuel Kant. Okay, I will give a quick recap also so that you are able to retain this. So, most of the mass moves to the center. A hot, dense central body is formed, which is the initial and the primitive sun. That is your proto sun. Okay, proto refers to primary, primordial, proto, all of this refers to the initial state. Okay, the remaining particle spreads out in a very flattened disc like shape, and the disk continues to rotate around the proto sun. Slowly and steadily, the materials in the disk, they have collided, and they have led to the formation of these individual planets. Okay, they have led to the individual planet formation, and you have the sun at the center. So this is Kantian explanation. Very quick recap, let's go for it so that immediately we are able to retain. Initially, the assumption was a large nebula. What is nebula? Nebula is basically nothing but a combination of cloud and dust particles and gas, right? So a large nebula basically indicating dust and gaseous particles. Okay. Now, this nebula was rotating slowly, was cold and rotating. Okay. If you are making notes, make notes in this point-wise manner, flowchart-like manner, so that it is easier for you to recall. The PDF, the annotations of the PDF will be provided in the link of the description also. But I would suggest everyone to prepare their own handmade notes so that you will be able to revise it and retain it also. So it was cold, it was rotating, and then this nebula, it collapsed. Why did it collapse? What was the reason for the collapse of this entire nebula, the gaseous nebula? What was the reason for that? It was very good. Gravity. It collapsed because of gravity. Okay? And that led to the collapse of the entire nebula. Once the collapse happened, after that, it became a rotating disk. Rotating disk. Where was the largest mass associated in this rotating disk? In the center. So all the gases, etc., they were particularly concentrated around the center. Now, as everything collapsed, then basically the speed of rotation further increased. Now, why will that happen? Why will the speed of rotation increase if everything collapses? Now, in physics, you refer to it as a principle of conservation of angular momentum. But let's presume I don't know anything about angular momentum. I don't know anything about conservation of angular momentum. Let us understand it from the basic aspects. Now, let's suppose if you have a larger object, right? A larger or a person spinning with the arms out. Okay. As you have in the skating tournaments, etc. Person skating and spinning with the arms out. They will have a speed of rotation. The moment they bring their arms inwards, you will find that the speed continues to increase always. Okay, so that is where, as you have the size decreasing and flattening, thereby the speed would always increase. So when this rotating disk was created, that is when the speed of rotation increased. Speed of rotation increased, isn't it? Now, this increased speed of rotation means what? You have the entire bulge at the center. Mass is heavy, outside the mass is less, everything is rotating. There will be a different speed of rotation in the outer part and the inner part, right? Because of that differential speed of rotation, you will find that basically the various different parts of this disk started separating from each other. Disk started separating, separating. And this formed ring-like structures around center. Now, this center led to the formation of the sun, and these rings eventually led to the formation of planets. Okay? This in its entirety is your formation of universe as per Immanuel Kant. Is this a correct theory? No. But why do we study this theory then if it is not correct? We study this theory to understand the evolution of our understanding of the universe. That is why we study this theory. Or, in simple terms, why do we study this theory? UPSC can ask this question. That is why we study this theory. As simple as that. Okay. We have nothing to do with Immanuel Kant. We have no sentiment attached to Immanuel Kant. Later on, as we move ahead, we will criticize Immanuel Kant also. So please don't get emotionally attached that such a wonderful theory was provided. But nonetheless, this is important to understand how mankind started talking about the evolution of universe. Okay. Now, where in NCRT this is situated, this is given? This is given in this particular place. One of the earliest arguments was provided by Immanuel Kant. Okay. And later modified by Laplace, that is nebular hypothesis. This is the portion which I have expanded upon, which also brings me to another point. In NCRT, when you study NCRT, it might appear as a single sentence, but then you need to dig deeper because for relevance in the examination. Otherwise, you will have the same kind of an approach. Sir, I don't know from where UPSC is asking these questions. Let's get angry at UPSC and so on and so forth. Okay. NCRT, these points and these single statements will be picked up and thrown at you even in a subjective question. And unless and until you know the details, you won't be able to solve those questions. Okay. Now, hereafter, basically, this is the entire formation: nebula, contraction, disk formation, condensation, and eventually leading to the establishment of the solar system. I hope we are able to retain this. This is a write up of the basic assumptions made by Immanuel Kant. The universe contained vast clouds of diffused gas and dust. The nebula possessed a slow rotational motion. Gravity caused the nebula to contract. Okay. As contraction continued, the rotational speed increased due to the conservation of angular momentum. This I have deliberately written here so that you have some technical words also which can be written in your answer paper. The increasing force inside flattened the nebula eventually in a disk. Now let's go for the critical analysis. You have the questions in the mains examination. Critically analyze the continental drift theory. Critically analyze the nebular hypothesis. So let's go for the critical analysis. What is critical analysis? You have to talk about the case of advantages as well as the disadvantages of the theory. Now, what are the advantages? First of all, it was the first theory which talked about the formation of the solar system, the entire solar system. Okay, so it talked about formation of solar system. I hope we are also making notes along with this. Okay, formation of solar system. Secondly, it was the first theory which talked about the formation of planets as well. Before this, no theory talked about the formation of planet. Every other geographer or scientist would say that this is a mere creation of God. So teleological theories were very prominent at that point of time. Right. So here, formation of planet was stressed upon. Then after that, the other theory, it also talked about why you have the eight planets. At that point of time, you had more planets which were considered. Pluto was also considered. Why you have these many planets? Why not only one planet around the sun? Right. So sun, formation of sun, and reason for rotation of the planets around the sun. Reason for movement of planet around sun. Okay. Now, what were the disadvantages in this? The lacunae. Think about it. I already told you, whichever portion the theory you are not able to understand becomes a criticism naturally. So, here, what was the disadvantage? First disadvantage, where did the nebula come from? We are presuming that there was a nebula. Where did the nebula come from? So, that is the first disadvantage. Origin of nebula. Okay. Then, where is it that the nebula, why is it that the nebula was rotating? We presume that the nebula was rotating, and that is when it collapsed. Nebula is the a kind of a cloud of gas and dust. Eventually, that is linked to a star because that leads to the formation of a star also. Okay, but then where did the nebula come into existence from? Okay, so that is where the origin of rotation. Why was it rotating? Then, solar system was considered to be the entire universe. No explanation about the formation of stars or any other galaxies for that matter. Only concentrated to solar system. Solar system. Then, in this entire discussion that we have we even once discussed about formation of moon or formation of other satellites across the various planets? Why was the moon created, etc.? No. So this is where formation of moons was not explained. Moons or satellites, not there. Okay. So now you have the advantages and the disadvantages associated with the Kantian nebular hypothesis. As I told you, later on, you basically have the case of Laplace, who was his student, his pupil. He basically modified it, right? And he basically ensured that there were some modifications, some of these drawbacks about the formation of nebula and its rotation was explained. But we don't need to go into the Laplacian theory of 1795. Over a period of time, 1800s was slightly silent in terms of talking about where these the universe came into existence, etc. Later part of the 19th century, that is later part of 1800s, again, when science and study of science picked up across the world, Oxford started picking it up as a particular subject. You had some of the US universities who were doing some great research. German geographers were doing some great research. After that period of time, you had some of the other theories provided. You had the theories provided by Jeffreys, Chamberlain, etc., and so on. We won't go into that detail as of now. Let's come to the theory which actually matters, which is provided even in the case of your NCRT. In the 1920s, right? In 1920s, you had an American astronomer named Edwin Hubble. The same Edwin Hubble on whose name you would have ratified the biggest telescope that the planet Earth had. Now you have James Webb, but for a long period of time, you had the Hubble telescope, which was the most powerful one, right? So here, basically, when we talk about Edwin Hubble was an astronomer and he was observing the universe. Now, Edwin Hubble observed something very unique. What was it? He basically observed that the various different celestial objects, stars, planets, everything, they are moving away from each other. They are not moving towards any particular force. They are moving away from each other. Okay. So that meant that basically the universe is expanding. The universe that we know is expanding. Why it is expanding, we don't know. Edwin Hubble did not know. But nonetheless, he could study this with the help of the wavelengths that these particular celestial objects they would emit. So, with the help of that, he basically came across a theory that is known as theory of expanding universe. Expanding universe. Okay. Now, NCRT here basically uses an example which is not perfect for that matter, but you should know that example. Imagine that you have a rubber balloon, right? That the ones that you use during the birthdays, the parties, etc. Now, if that rubber balloon, let's suppose you have a kind of a deflated balloon. Now, this balloon, let's suppose it has got multiple dots. When you inflate that balloon, as you inflate that balloon, what happens to the dots? The dots move farther away, the dots move away from each other. Similarly, a similar impact was expected in the universe, that everything was actually moving quite distant and quite far away from each other. Now, what is the implication of this? Let us understand the implication of this. Then we will come to the Big Bang theory. So, today, the materials in the universe are here. That means 50 years ago or 5 million years ago, they would have been closer to each other, isn't it? They would not have been here. That means maybe 100 million years ago, they would have been much closer to each other because the universe is expanding as of today. So if you interpolate the time or if you take back the time, right? So it would have been closer to each other. For example, two people are moving away from each other. 1 hour ago, they would have been closer. 2 hours ago, they would have been further closer. 5 hours ago, they would have been at the same place. Similarly, you basically would have the particles which would have been closer 100 million years ago. Now, these objects or stars would have been much closer, maybe 100 billion or 500 million years ago, right? They would have been much closer even before that, much closer even before that. So, based upon this theory of expanding universe, you had two individuals. One was Georges Lemaitre and other was Gemov. Okay, Lemaitre and Gemov, they basically interpolated this and said that look, if everything would have been much closer earlier, what if everything that we see around us was a part of a single mass? That is singularity. Now, this single mass would have exploded. And that is where the power of explosion was so high that materials are still moving far away because of that ancient explosion. Again, let me repeat this. Edwin Hubble said all materials are moving away from each other continuously. That means going back in time, they would have been closer. Going back further in time, they would have been much more closer. And at some point of time in history, Lemaitre and Gamow, they basically said they would have been together. It would have been one mass. And that one mass would have exploded. And that is why the materials are still moving far away from each other. So that one explosion has led to the entire universe formation. So that one explosion was very important. And that is what they termed as the Big Bang theory, whereby they said that this one explosion happened. And this one explosion started pushing the materials away from each other. And eventually, the materials, they are still moving away from each other. And that is why we have an expanding universe. Okay, I hope this is understood. Let us quickly have a recap of this. So, theory of expanding universe provided by whom? Provided by Edwin Hubble. Okay, now Edwin Hubble, he basically talked about that everything is moving away from each other. Now, materials moving away. Materials and objects continue to move away from each other. And how did he come across this conclusion? Based upon study of the light emitted by the stars. Okay, for example, let's suppose if I have my mobile phone here and I use the torch of my mobile phone, it will give me some amount of light. If the mobile phone is here, the light will change. If it is here, light will change. So, by studying this change in the light provided by these various stars, he came upon the conclusion that everything in the universe is actually moving. So, based upon the study of wavelength, right, emitted by the objects. Okay, by the objects. Now, based upon this theory, there was the intrapolation. Intrapolation was what? Intrapolation was provided by Lemaitre and Gamow. And this interpolation was what? That long time back, there would be a single mass and that would be referred to as singularity. Interpolation means taking something which is back, right? For example, right now I am here, right? I have come from this place. So if I have this information that this person has come from this place to this place, where would he have been 50 minutes ago or 1 hour ago? That is interpolating, going back, right? Deducing backwards. Okay, so that is interpolation. So Lemaitre and Gamow, they basically deduced that there would have been singularity, and this singularity would have exploded. Yes, correct, Deepika. Exploded. This explosion would be referred to as the Big Bang. This is the theory, which is something which has evolved throughout the 1900s, and this is the theory which we have to be concerned about. So, what does the Big Bang theory tell us? The Big Bang theory tells us that long time ago, around 13.8 billion years ago, there was a single mass, and this mass had very high temperature, and also was experiencing a lot of pressure. Okay, if you crush something from all sides, right, it will crumble, it will try to explode. So, very high temperature, very high pressure. Okay, now due to this very high temperature and very high pressure, this singular mass exploded. Okay, this basically exploded. And this explosion, initially, it started moving materials at a speed which was faster than the speed of light. Right? It material started moving away at a speed which was faster than speed of light. Now, even though we won't go into the scientific explanation of Einstein's theory, but Albert Einstein had said that energy and mass are interconvertible if they move at a speed faster than the speed of light, right? The oversimplification of E is equal to mc square. Initially, the temperature was also very high. The temperature was to the tune of 10 to the power 32 degrees Celsius and more. Slowly and steadily, temperature started reducing after the explosion. Temperature started to reduce. As the temperature started to reduce, what happened? Everything started to cool down. This is when initially you had the formation of small subatomic particles, which you will study in your science and tech as quarks, for example. So you had the formation of, after temperature started to reduce, you had the formation of this cooling down led to formation of subatomic particles. Now these subatomic particles like quarks. Okay, the muons, quarks, etc. They slowed down to the speed of light and even further. Okay, and eventually, when lot of these quarks got created, electrons and protons got created. Electrons and protons, they got created. Now, imagine if you have a universe where you have electrons and protons. Now, one electron will move around one proton, right? That, like that, you will have formation of atoms. So, the earliest atomic formation was that of hydrogen with one electron and helium with two electrons. These were the initial gases which were present in the solar system. Later on, the electrons, they combined in different shape, proportion, etc. And you had multiple other particles also getting created. Okay, I hope this is clear. This is the overall graphical representation or a step-by-step representation. So basically, and observe here, what I want you to observe is the time after the Big Bang. So all matter, energy, and space and time were in an extremely hot and dense state. What would be referred to as singularity? Explosion happened, and that was your Big Bang. This was 0 second. Okay. Now, 1 second is at the fourth stage. We are talking about 10 to the power minus 32 second. Imagine how small a time window is, 10 to the power minus 32 second. Very small fraction of a second. Now, initially, the universe expanded exponentially in a tiny fraction of second. And that is where it started moving faster than the speed of light. That is why the size was massive. Then, from 10 to the power minus 2 to 1 second, temperature reduced. As universe cooled, fundamental particles formed, quarks, leptons, and some of the antiparticles. Eventually, they combine to form protons and neutrons. And that led to the formation of hydrogen and helium. Now, over a period of time, as this was happening, multiple atoms combined with each other because it was a randomized explosion. Materials were moving in a randomized manner. So materials, they got together in different shape and proportion. And that is when you basically had the recombination. And that is when different types of atomic structures and molecules, they got created. Eventually, let's suppose here hydrogen is present, here some hydrogen is present, gravity will pull them together, they are forced to combine. You have energy which is produced, nuclear energy which is produced, and that will attract more hydrogen and helium. Like that, initial stars getting created. Okay, so like that, you basically had the creation of the first of these stars. Multiple such explosions would happen in the universe, and that is when you again had the formation of what Kant had talked about, nebula. Nebula, that is a gas and dust particles. Okay, I hope this is understood. So, a quick recap: 13.8 billion years ago, you had the Big Bang. Okay, the Big Bang, right? Now, after this, basically, now there are multiple different scientific stages to the Big Bang also, but it is not important for us from a UPSC perspective to go into that much depth. So we are not going to extract the leather out of the ball in this case. So the Big Bang happened eventually, and initial exponential expansion, right? Exponential expansion. After that, cooling down was something which was observed, temperature reduced, then quarks and other subatomic particles formed. This is all between 1 second of the Big Bang to a few minutes to the Big Bang. These quarks and subatomic particles combined to form electrons, okay, and protons. Atoms got created, formation. Atoms combined to form hydrogen and helium, these particles were forced to collide due to gravity. As they collided, nuclear energy was produced, birth of stars. I hope this is clear now. The entire story from the Big Bang. Okay? Now, here, basically, it is the case of the entire universe getting created 13.8 billion years ago. 13.8 billion years ago. Triparna, I hope this is clear. Okay. Now, 13.8 billion years ago, this was created. Now, this theory also has got its drawbacks. Okay. This theory also has got its criticism. What is the criticism? Think about it and let me know very quickly. What do you think is the criticism of the Big Bang theory? The major criticism is that how did the singularity come into existence? From, yes, correct, Pratima. Where is it that the singularity come into existence from? And why do you have the singularity having very high temperature and pressure? That is the assumption of the Big Bang. Okay. So that is the basic criticism of Big Bang. That is where you have some of the physicists who have given the theory, and this is not given in NCRT, but if you don't get confused, it's okay to know about it. Yes, the cause of explosion, the cause of high temperature. The physicists give an idea or the theory of an oscillating universe, correct? That every few billion years, there is this Big Bang which happens. That is, and listen to this carefully, you have the singularity. Singularity explodes, and materials get thrown away. They move far away from each other because of the force of explosion. But somewhere down the line, 40 billion years, 30 billion years, 100 billion years, that movement away will stop because the energy of explosion would have died out. Once that movement away stops, then each and every star will start to pull each other together. The galaxies will start coming together. Collisions will happen. Mass will increase. And eventually, everything will again collapse to a singularity. Again, after that, they will explode. Again, they will collapse into singularity. So that is basically the concept associated even with the uh, a kind of a very theoretical concept of multiple universe, the multiverse concept, that you can have multiple singularities and multiple universes at the same time. So, but then not given in NCRT, we are not going to explore this. But I hope till now it is absolutely crystal clear what is the Big Bang theory, what is its criticism. Now, this was created 13.8 billion years ago. But when we talk about the solar system, planet Earth, its formation was very different. So, that is something which started around 4.5 billion years ago. Okay. Around 4.5 billion years ago, again, you had basically a solar nebula. Solar nebula. Nebula is what? A cloud of gas and dust. And dust. Now, the mathematical calculations, they tell us that this nebula collapsed. The reason for the collapse, there is the estimate that nearby a star would have exploded, and a an older sun would have exploded. So because of that explosion, all this gas would have been forced to collapse. Okay. So collapsed because of, this is the modern theory I'm talking about. I'm not talking about Kant anymore. So that is basically due to nearby explosion. Okay. And that led to the formation of the sun and the dust particles around. Okay. Now let us come to the evolution and the formation of Earth, evolution of lithosphere, evolution of atmosphere and hydrosphere. So basically, around 4.5 billion years ago, you basically had the solar system where the sun was just created. It was not as stable as it is today, right? It was still getting created, lot of explosions, lot of gases, lot of energy. And what you see in the image here, a host of dust particles rotating at very high speeds around the sun. Now, these particles, it is invariable that they will come in each other's path, they will collide with each other, isn't it? So, when they would start to collide with each other, what would happen? Now, there are different types of collisions. If two materials they move towards each other and then collide, they will fragment, break away, multiple small parts. But if a material is coming like this, another material simply collides. What will happen? It will add on, isn't it? Something like this, where you see a material which is moving, another material also coming in its path. It basically sometimes gets disintegrated, but in many of the cases, the temperature is so high that it simply adds on to each other. So, initially, 4.5 billion years ago, you had these series of collisions. Now, pay attention here for 2 minutes and you will understand this concept. Now, these collisions, what would it lead to? It would basically lead to increase in size and mass. The weight of this material would increase. Okay. Collision would produce enough temperature that the materials would get welded together. Right. So that is why the size and the mass would increase. Now, if the mass increases, the force of gravity also increases. For example, the gravitational force extended by the sun will be much higher than the gravitational force extended by the planet Earth. So, if the mass increases, force of gravity increases. Now, once the force of gravity increases, means what? It will lead to, will attract more particles, attract more particles. As it will attract more particles, what will happen? More collisions will happen, and this will be a cyclic process which will continue, isn't it? What is the end result of this? The end result is, around the sun, you will have these large chunk sized objects which are moving in a particular place, right? So that is what would eventually lead to formation of very large objects which would be referred to as planetesimals. Planetesimal is basically building block of the planet. Building block of planet. Now, these planetesimals would collide with each other and eventually They would collide, they would produce enough heat that everything melts. And that is when you had the formation of the proto Earth. Proto Earth. Proto means primitive. Proto Earth formation was something which happened. Now, what was this proto Earth? Proto Earth was this planet which was molten, right? It was molten, okay? Everything was in a liquid state. It had some gases around it at this stage. This was basically 4.5 billion years ago. This is your proto Earth. No landmass, no water body, no oxygen, no carbon dioxide, nothing. It was absolutely in a molten state. And this is where you had the very little amount of gases, that was some amount of hydrogen, some amount of helium was present. That's it. No oxygen was present on planet Earth at that point of time. This atmosphere is also primitive atmosphere. So this atmosphere would be referred to as proto atmosphere. Now, at this point of time, as I told you, the sun was still evolving. So, a lot of charged particles from the sun would bombard the planets on a daily basis. They simply removed the hydrogen and helium from here. Very little amount was left. Why only hydrogen and helium? Because remember, the gases which were present in the universe, they were basically hydrogen and helium, which had led to the formation of the sun also. Okay, right? Uh, is spreading enormously and continuously. What is spreading it into? It is expanding, the theory of expanding universe. And that energy is provided since the time of the Big Bang. Okay. Now, at this point of time, you had something which was a very simple process in the molten earth which happened. And for that, I want you to think about a very homemade example, a very basic example. Let's suppose you have a jar. Now, in that jar, I put in water, I put in, let's suppose, oil, I put in, let's suppose, honey. Now, will they all mix together automatically into a uniform liquid? No. Chances are that honey will settle at the bottom, isn't it? Water will float on top of honey, and then oil will be floating on top of water, isn't it? So, what do you observe here? Arrangement in layers. Molten materials, molten materials will arrange themselves in layers. Arrangement in layers. This process of arranging liquids in layers, this is what is referred to as stratification. I hope till here it is absolutely clear. Okay. Heaviest materials will sink, lightest materials will float. So initially you had the phase of accretion. Phase of accretion led to the formation of planetesimals. Planetesimals, basically, accretion means what? Coming together. The formation of Earth is explained with the theory of accretion. Accretion is accumulation, coming together. So planetesimals would combine, lead to the formation of protoplanet, right? And this protoplanet would be in a molten state. Molten state. Then you would have the phase of stratification. Means heaviest materials would be at the bottom, lightest materials would be at the top. Now, which were the heaviest materials at this point of time? You had the heaviest materials to be iron, nickel, etc. These were the heaviest materials. So these heaviest materials, they simply settled at the bottom. The lightest materials like the silicates, etc., they came to the top. Okay, so that is basically where you had the case of the planet Earth being arranged in a kind of a layer shape, with the heaviest materials like iron and nickel settling at the bottom, forming even the present day core. Even today, the core of planet Earth has got iron and nickel. You guys would have ratified this from your childhood days. But why only iron and nickel at the bottom? Why not silica at the bottom? This is the reason. 4.5 billion years ago, there was the phase of stratification. And the lightest materials like silicates, oxides, etc., they came to the surface. Okay, till here it is clear. Proto atmosphere was also getting eroded by the solar winds. Now, while this was happening, there was another large object to the size of Mars, which was moving very close to the Earth's path. It is said that this large object eventually collided with planet Earth, right? So you had a large Mars sized object which was moving very close to planet Earth. Planet Earth was molten, right? This Mars sized object was known as Theia, and this was your molten Earth. Now, this Theia, when it collided with a huge force. It is said that Theia broke into multiple pieces, and portions of Theia, they started sinking within planet Earth. Okay, Theia started sinking underneath planet Earth. But what also happened as a consequence was that Earth, which was liquid, was disturbed. Now, if this material collides with Earth, let me ask you a simple question. Out of place 1 and place 2, which is the material which will be disturbed? 1 or 2 after the collision? Obviously, place 1 will be disturbed much more. So, these materials basically were thrown away. So, these materials which were thrown away from Earth in molten state, Earth's gravitational pull did not allow it to go very far. It held it in its place. Over a period of time, it solidified. And that is when we had the formation of moon. Now you know why moon consists of lighter rock materials as compared to planet Earth. Because the surface was basically carried away after the collision. Moon does not contain heavy elements. Moon contains lighter materials. And when did we come to know about this? We came to know about it during the Apollo missions. The Apollo missions to the moon brought back the rock samples, and people were surprised to know that this has got the similar origin as compared to planet Earth. This is the process of formation of moon. This is known as the giant impact hypothesis. Impact hypothesis. Okay. I hope you know this. Now, recent scientific explorations have indicated that deep within the mantle, there are two extremely dense materials which are lodged into that place. One underneath Africa and one underneath the Pacific Ocean. Geographers estimate that this is actually the remnant of Theia. So that is where we have the evidence that Theia actually collided, and you still have the evidence of it in the lower portion of the mantle of planet Earth. Okay? So this is basically your entire giant impact hypothesis and the formation of the Earth and the formation of the moon that you understand. Now, the Earth was basically after around 3 point or after around half a billion years since its formation, Earth had started to cool down. Now think about it. Let's suppose you have a pan, right, in which you are boiling milk. The milk is boiling. After that, if you shut down the stove, the surface will cool down. It will form a kind of a thin crust like layer. But if you dip your finger into that milk, the lower portion will be very hot, isn't it? Same was the case with planet Earth. The cooling started happening outside, from outside. So, planet Earth, the cooling started to happen from outside. So, you had the weak crust which was created. Weak crust. Now, you also observe today when the milk cools down, you will have some wrinkles which develop. It is not absolutely plain. Some areas, some wrinkles will develop. Like that, this crust also had development of some wrinkles. Some areas were at a height, some areas were at a depression. But nonetheless, it was very weak. Inner portion was molten. It included gases. How gases in the interior? Very simple. If I melt iron, it will be liquid. But if I melt iron oxide, what will happen to the oxygen? Oxygen will convert into gas. So inside, there were a lot of gases which were trapped as the outer surface cooled down. Now, these gases will try to come out, isn't it? This is when you had the planet Earth entering into the phase of degasification. Every day, hundreds and thousands of volcanic activities would happen on a daily basis because the crust was also not very strong. The crust was very weak. So, volcanic events would be very common. So, every day you had a series of volcanoes. And these volcanoes, they introduced newer gases into our atmosphere. So, our atmosphere, which earlier had only hydrogen and helium, now got new gases. Which were these new gases? Even now, oxygen was not there in large amount. Newer gases were nitrogen oxides, ammonia in large amount, carbon dioxide, sulfur dioxide. Okay, these were the gases which were present, and one secret ingredient was there, and that was water vapor. Water vapor was present at high temperature in the interior. Hydrogen and oxygen had combined. So, this water vapor was also introduced into the atmosphere. So, this is the second stage of your evolution of atmosphere. Evolution of atmosphere. Okay. Thereafter, Across this planet Earth, this temperature further reduced, cooling down further happened. All this water vapor started cooling down along with sulfur dioxide, etc. So it formed very dense clouds. Dense clouds which covered the entirety of the planet. Now, when the sunlight was blocked, what would happen to the rate of cooling? Rate of cooling would further increase. So that is when you basically had increased cooling and crust solidified. Solidified. Okay? But then these clouds were present. These clouds basically consisted of multiple different materials. Multiple different materials like sulfur dioxide, nitrates, etc. It was a very acidic kind of a cloud which was there. But as it cooled down, eventually condensation happened and it brought torrential rains. What is torrent or torrential? Torrential refers to an unending kind of an activity, right? A series of unending activity. So, this is when the planet is said to have experienced rains continuously. If it rains in your area for 2 days, your drains get flooded. If it rains for 4 continuous days, your roads get flooded. In cities like Bangalore, if it rains for 3 continuous days, the entire Bangalore region gets flooded. In this series of torrential rains, planet has gone through multiple series of torrential rains. In this series of torrential rains, it is expected that it rained for 7,000 to 10,000 years continuously. And this led to the formation of what we refer to as the blue planet. Still, our atmosphere did not have lot of oxygen. But in various different areas, you had the oceans, primitive oceans, which were created. At that point of time, continents were not present, by the way. Only you had the presence of oceans. That is how you had the formation of the blue planet. Now, in this, the oceans which were there, the oceans basically were a unique mixture of various different types of compounds, not the purish kind of a water that you observe. Now, within these oceans, chemicals were present, isn't it? So that is when you had, utilizing those chemicals, a cell came into existence. Oceans on the solid crust, obviously. A cell came into existence. The blue green bacterium or cyanobacteria came into existence. Now, this bacteria, what it could do, it could basically utilize the chemicals and produce energy. It learned how to live. And upon learning how to live, basically, they started to multiply. And in this process, they would carry out the process which is still carried out by many organisms, that is chemosynthesis. You had the photosynthesis by plants, you have the chemosynthesis utilizing chemicals, and they produce oxygen. This led to the origin of life. And when life came upon planet Earth, this is referred to as the first great oxidation event. Oxidation event. This started happening almost 3.5 billion years ago. But then, eventually, later on, you had multiple evolution of life, Almost 500 to 400 million years ago, you had the development of plants because carbon dioxide was present and some of the primitive plants could grow, isn't it? Around 500, 400 million years ago. Now, these plants would carry out photosynthesis. Okay. In our environment ecological lecture, I will talk about the evolution of life, the extinction also. But this is just to touch upon the origin. Now, upon this photosynthesis which happened, this produced oxygen. It is at this particular stage around 400 to 600 million years ago. That is when oxygen concentration in atmosphere started to increase exponentially. The second mass oxidation event. And that is when you have the third stage of the atmosphere, that is the modification. And by the way, how did the species react? When you had the sudden increase in oxygen, the cells in the body of the organisms, they could carry out metabolism very easily. Okay, so basically, they could produce more energy. So the species suddenly started producing more energy. They started growing larger. And that is when planet Earth entered into the era of giants, where you had very giant sharks. You had the case of even the millipedes and the centipedes that you have today. They had the size of 2 meters and beyond. That is when planet basically entered into the era of giants. And that is how the life originated on planet Earth. Okay? So what started with the with the planetesimals, protoplanet, evolution of atmosphere, introduction of new gases through degasification, cooling. That is when you had the new gases of ammonia, carbon dioxide, sulfur dioxide, etc. Then formation of these clouds further accelerated the rate of cooling, torrential rains, formation of primitive oceans, genesis of life. Okay. Now, with this limited information, let us attempt this question. Consider the following statements. Earth's magnetic field has reversed every few 100,000 years. Let's suppose I don't know, I have no clue about this. Second, when the Earth was created more than 4,000 million years ago or 4 billion years ago, there was 54% oxygen and no carbon dioxide when Earth was created at this point of time. Now, is this statement correct? No. Then, when living organisms originated, they modified the early atmosphere of planet Earth. Correct? The oxygenation events happened. So we know that 3 is correct and 2 is incorrect. Eliminate the portion where 2 is given as correct. And 3 is also correct. You have only one option. C is the correct answer. I hope this is something which is understood. This is something which is digested, and you have also prepared your basic notes. This is a question which many candidates refer to as being very difficult. But again, I would say if you simply refer to the NCERT, you will be able to get this correct. If you have liked that session, put that in the comment section below and just bless us with your like, share, and the subscribe button. Tomorrow, we will be talking about the interior of planet Earth and the structure of planet Earth, including the asthenosphere, why the outer core is liquid while the inner core is solid, geomagnetism, etc. That is something that we will be talking about. Age of Earth is estimated to be 4.5 billion years ago. Water bear is an evolutionary species, not came from meteor shower. Evolution of life happened on planet Earth from cyanobacterium and eventually through multiple stages of evolution and extinction. Okay, so I hope this is internalized. This is understood. I will ask you multiple choice questions from this, but we will restrict it here today. Tomorrow, we will meet again for structure, interior of planet Earth, and we will move ahead. Thank you for all your patience. We will meet again tomorrow. Till then, take care of yourself. Goodbye. Thank you.